Let's introduce the idea of dealing with parametric curves or parametric data by looking at some data I got. One day my sister flew home for a holiday or something, and she got off the airplane and called me and said, "You would not believe how crazy that flight was. You know, we were coming in for a landing, and then all of a sudden we were turning and turning, and then we started turning the other way, and it was the hardest turns I've ever felt in an airplane." And so I did what any good big brother would do. I went to the internet and looked up the flight data for that airplane to figure out what track it had taken. And here's the data we got. This is real data. And so we have like minute by minute, how many kilometers was the airplane from the landing airport horizontally, like in the x direction, that would be longitude. And how many kilometers was it from the airport in the y direction? That would be the longitude. So what will happen if we graph this? So 0, 0, then that's the minute that it actually arrived at the airport. Let's graph it. And I'm going to use dots with connecting straight lines. So let's think about this graph. It would be good to label the graph, right? So what goes on the x-axis, what goes on the y-axis? Take a sec to think about that. I'm going to tell it I want x-axis and y-axis labels. So what goes on the x-axis here? Look at these numbers and look at the way I highlighted the data. What goes on the x-axis? Well, these numbers, x and y values, are like between 0 and 90 or so, sometimes negative. But they aren't around like 320, so we can kind of tell that this axis is using the minutes into the flight. So we'll label that time in minutes. And then what's the y-axis here? It actually has two curves on it. So it's not just one thing, but what would you say it is overall? It's kind of distance from the airport in the x direction and in the y direction, even though they're both on the y-axis of the graph. So we could say, let's change this. Distance from airport kilometers, x or y direction. Does this give you an idea of like where her plane was and why she said it did some kind of crazy circles in the sky? I'm not seeing any circles going on here. So maybe this isn't the best representation of what was going on. What would be a better way to graph it? Let's keep in mind that when you highlight a block of data in Excel, Excel uses whatever the leftmost column of what you highlighted is as the x-axis. At least usually it does. Sometimes it decides not to do that. That's its own story. But if I want to plot the x location of her plane on the x-axis, I have to not highlight that, the time, as the leftmost column. I have to highlight this as the leftmost column. And if I want the y location on the y-axis, I would do this. So I'm going to highlight just these two columns and plot that. Again, dots with straight connectors. And does that make a little more sense as to why she would have said, oh, we did these circles in the sky that weren't just kind of let's delay and let other airplanes get off the runway or whatever, but they were much tighter than your usual flight delays. So what are the x and y axes here? What makes sense? Let's move this up here. And we'll say, what's this axis? That should be our x kilometers from the airport. And this one should be our y kilometers from the airport. So this graph itself is a parametric curve. Where these are two ordinary xy curves where x is time and y is some sort of position, either latitude or longitude. You might see I've got a compass kind of polar rose here that we usually put on maps. Which one of these two graphs, or maybe both or neither, should get a compass rose like this that's telling us north and south and east and west? Well, the horizontal axis here is in time, which does not make sense as an east-west kind of thing, or north-south. Where the x-axis here is x kilometers from the airport, that like longitude. So that does make sense as an east-west thing. So we're going to put this on the graph to denote that this is like looking down at a map, kind of like that seals, the tracking the seals graph we had earlier. Now we might ask, how is time represented on this graph? Because time was not included in what I graphed, right? This graph, if you see what columns it highlights when I click on it, it's not including the time. How is time represented on this graph? Take a sec to think about that. Well, we're kind of lucky that time was going in 1 minute segments here. So this dot is the very first point at time 323, and then this next dot is at time 324, and this next dot is at time 325, etc. So the dots show us which row in the data it was, and since the data was equally spaced 1 minute per row, it also shows us minute by minute where the plane was. So time is represented as movement along this path. It's kind of even hard to figure out what was going on there. We could come back and look at it and say, well, the x kilometers were decreasing reasonably, and then all of a sudden turned around. So we were going like this, and then all of a sudden turned around either like this or like that. We'd have to look at what the y values did. They all of a sudden increased, so it probably increased in y and came around this way first. So that's the kind of graph interpretation for parametric curves. That's kind of handy, but we'll be able to animate it in Desmos later. So that's an introduction to parametric curves from a data set. Some other questions we could ask for this data set in particular. She said the turns were sharp. How sharp were they? How much g-force? Does knowing how quick of an angle it was determine how much g-force? Well, if you went around that same path but at a snail's pace, it would have a lot less g-force than if you were doing it at jet speeds, right? So this seems like it would depend on the speed at each point in time. So how do we determine that? We might also ask, how far did the plane travel? That's kind of like arc length. And if we had data for all the planes in that area and we saw 2 tracks overlap, does that mean those planes collided? Well, you know my sister survived, so probably not. But you could ask, how close did they come to colliding? And that's another thing we'll think about.